Hi folks, we're going to start Chemistry Vodcast 1.3 tonight. We're going to talk about scientific notation, sometimes called exponential notation. The basic idea behind it is that we've got really big and really small numbers in science. These are two of the biggest numbers that we use a lot in chemistry and physics. And those are obviously too unmanageable, so we need a way to sort of crunch them down and make them a little bit easier to handle. So we're going to talk about the two rules for that. The first rule is pretty simple. We basically only want one number to the left of the decimal, and this doesn't say this in the rule, but make yourself a note. It has to be a non-zero number to the left of the decimal. Okay, so wherever your decimal is, you're going to move it until it's right. There's one number to the left of it. So if we got 480, we're going to put the decimal to the right of the 4. So the 4 is to the left of it. There's one number to the left of the decimal. Second rule is how many spaces you move the decimal. That's the exponent. So we're going to put times 10 to some exponent. In this case, we moved the decimal 2 places. And since we moved it to the left, it's a positive 2. If we moved it to the right, it would be a negative 2. Okay, so we're going to go through a bunch of examples so you can really get a good grasp on how this works. So we got, on this first one, we got 22,400. Okay. And an easy way to remember a lot of this is that usually big numbers have positive exponents. Small numbers, like you can see 3 and 4 here, are going to have negative exponents. Okay, so we know we want to move our decimal to in between the 2's. It initially is to the right of the zeros, so we move it. That's 1, 2, 3, 4 spaces. So it becomes 2.24 times 10 to the 4th. So we go to the next one, 1, 2, 3, 4, 5, 6 spaces to the left again. So that becomes 7.2 times 10 to the 6th. 6 is how many spaces we moved it. Since we moved it to the left, that's a positive number. Okay, so what about the smaller numbers? Okay, what happens then? So I move it 1, 2 spaces, okay, to get that 4 to the left of the decimal. Remember, 0 can't be the number to the left. So 2 spaces, but since I went to the right, it's times 10 to the negative 2 instead of positive 2. Okay, and we'll see another example of that here in number 4. So 1, 2, 3, 4, 5 spaces to the right. So we're going to have 6.0 times 10. There's always that times 10 scientific notation. To the negative 5th. We moved it 5 places, and since we moved it to the right, it's a negative. Okay, couple other quick examples here. This one looks much like the initial one that we had. I don't know why all my numbers started with 4. But 454, okay, move it 2 spaces. 4.54 times 10, we moved it 2 spaces, so 10 to the 2nd. And in the next one, we move it 1 space, okay, so it becomes 3.14 times 10 to the negative 1. It looks like some of these numbers, you're like, why would I do this? This seems more complicated. It's more the process of knowing how it comes out. And a lot of times calculators will give us answers like this. So number 7, we move 3 spaces to the right. Okay, so negative 3, since we moved to the right, 3.06 times 10 to the negative 3rd. And again, in number 8, we're going to move many spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. Remember, we got to get that 5 to the left. Okay, so 5 times 10 to the 8th. You'll notice there's no 0.0 because that wouldn't accurately reflect the precision that we've got going on in that particular number. Okay, so let's jump back then to our initial 2 examples. Again, these are really important numbers in science. We're going to apply the same process. So the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 spaces. So we're going to have 6.023 times 10 to the 23rd. Okay, and that's obviously the case where we did need to put in scientific notation. I couldn't even get that first number in the calculator, but that scientific notation one I can. We'll talk here in a minute about how to get that into the calculator. So the next one, so far 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. A lot of spaces. Really, this is why I separated out the numbers so you can kind of count the zeros in groups of 3 to be able to figure this one out. So we're still cruising along. I think right now we're at 31, 2, 3, 4. Okay, so That's 34, and since we moved to the right, it's negative 34. So 6.626 times 10 to the negative 34th. We'll use this a couple times this year in chemistry. This is Planck's constant. We'll use it a lot more in physics. The first number, super important, as you can see the little note there. You'll see it 1,000 times. Sometimes, occasionally, it helps too if we have a number that's in scientific notation but isn't going to be a really big number, like the exponent is small. Sometimes it's just easier just to expand it back out. So write the number. And then if it was a positive number, we got to be positive by going to the left. So to expand it, we go the opposite way. So we go to the right. So we move it 2 spaces to the right. Any empty spots we fill in with a 0. So that number now becomes 890. Same thing if we're going the other way. It's just that negative numbers, we went to the right initially, so we reverse it now. So we're going to go to the left. 3 spaces. 1, 2, 3. Put the decimal point, fill in the blanks with zeros. That becomes our new number. Now it's easier to tell where the decimal is if you put a 0 in front of it. Remember that 0 doesn't count. If you remember sig figs, those leading zeros don't really matter. They're just placeholders for us there. Okay, so how do we put this in a calculator? Well, the easiest way is to use the EE button on your calculator. Most of the calculators in class, and most calculators, you're going to hit the second key, and then you're going to hit some other key that has an EE above it. You always want the EE. There are other ways, but this is the easiest. I'm going to show you here exactly how to do it. So I'm going to take those numbers that we just had a little bit ago that I just expanded, 8.9 E, okay, I hit second EE, okay, or that second and x minus 1 key, put in the exponent 2, and it was 890, just the same way we just expanded that. We're going to do the same thing for that other number that we expanded, 6.7, I hit second and the EE, negative 3.067. Really important there to make sure that you hit the negative key, not the minus key. So how do we do calculations with scientific notation? Now, really, punching them in the calculator is the easiest way, but sometimes you don't have a calculator, and so some of these you can do by hand. Basically, the way it works is for multiplication, division, pretty simple. If you're multiplying, you multiply the coefficients. The coefficient is the front part of the number, the non-10 to whatever power part. So in this case, 2.0 times 3.0, 2 times 3 is 6. And then for the exponent part, you're going to write times 10, and you're going to add the exponents. So 3 plus 4 gives us 7. Pretty simple. Same thing for division, except obviously you're not dividing in this case. You're not multiplying. You're going to divide the coefficient. So 8 divided by 2, that's going to give us 4. So we got 4.0. And then instead of adding the exponents, we're going to subtract them. So it's times 10. We go up and do the math to figure out what it is. It's 6 minus 3. 6 minus 3 is 3. So that's our new exponent. Addition and subtraction, a little bit more complicated. You have to make the exponents the same before you can do the math. So in this case, what you usually want to strive for is to make the smaller number bigger. Easier to do the shift that way. Okay, so we're going to turn that 13 into a 10 to the 14th. To do that, what we have to do is if we move the exponent up 1, we move the decimal to the left 1. Okay? So however many spaces you had to move the exponent up, that's how many spaces you move to the left. So now what we got is 0.20 times 10 to the 14th plus 1.5 times 10 to the 14th. Okay, so we're going to add those up. Basically, you just bring the 10 to the 14th part down. Okay, you're not going to do anything else with it. Once you've got them the same, that's what your answer is going to end in. Okay, so we're going to circle that, just bring that down. That part's done. The other part is just addition. Okay, add that up. 1.5 plus 0.2 is 1.7. That's our final answer. Thanks, folks.